we'll be talking about, so we'll be discussing about Anova. I'm sorry, I will not be able to open my video. I've not been opening my video for a couple of classes now because of my internet connection. So the audio seems to be stable, than including the video features. So today we'll be discussing about analysis of variance. So at the end of this section, you should be able to define Anova and its significance. You should be able to highlight the general assumptions of Anova. You should be able to explain when to use a one-way or two-way Anova, that is when to apply it in your research. You should be able to perform one-way and two-way Anova tests in SPSS. You should be able to report Anova test results in APA format. You should be able to highlight how two-way Anova test works. You should be able to highlight how the absorption of two-way Anova. You should be able to highlight the Anova. Okay, sorry. Hey, I did not request for your name and student ID, right? You have started again this week. Okay, so you should be able to report Anova test result in APA format. You should be able to highlight how two-way Anova test works. You should be able to highlight the assumptions of two-way Anova. You should be able to perform and interpret two-way Anova tests in SPSS. You should be able to describe chi-square tests. You should be able to compute and interpret chi-square tests of independence on SPSS. And finally, you should be able to enter questionnaire data on SPSS. All this, among others, are what we'll be discussing in today's section. So to start with, we have done a few tests. So one of the tests that we have not actually touched much is the Anova, which is an acronym for analysis of variance. Anova is a statistical test used to analyze the difference between the means of more than two groups. If you want to check the difference between the mean of more than two groups, then you can use Anova. The null hypothesis of Anova is that there's no difference among group means, while the alternate hypothesis is that at least one group differs significantly from the overall mean of the dependent variable. Anova determines whether the group created by the level of the independent variable are statistically different by calculating whether the means of the treatment level are different from the overall mean of the dependent variable. So if any of the group means is significantly different from the overall mean, then the null hypothesis is rejected. Anova uses the F-test for statistical significance. This allows for comparison of multiple means at once because the error is calculated for the whole set of comparison rather than for each individual two-way comparison, which will happen with the t-test. Now, the F-test compares the variance in each group mean from the overall group variance. If the variance within group is smaller than the variance between groups, please get this up. If the variance within groups is smaller than the variance between groups, the F-test will find a higher F value and therefore a higher likelihood that the difference observed is real and not due to chance. Let me see. In the end, please tell how many sample size SPSS need to be used, and sample size is small, then which one to use. We have discussed about sample size last time, and I believe I've shown you how to compute sample size, which is one of the tools that can be used for that purpose is RAWSoft, if I'm not mistaken, RAWSoft sample size calculator. So I would advise that you check your previous slide in this regard, please. Okay. I put the screenshot, I give you samples. I also give you the formula that can be used to compute sample size manually. So you can explore whichever one that you want to use among them. If you want to use the two, just enter your data, enter the values that are there, then click on compute, then to tell you the kind of sample size that needed to be used for your research. Now, Anova comes with certain assumptions. Assumptions of the Anova test are the same as the general assumption of any parametric test. We have been working with some of these assumptions from our previous tests. So we're still going to continue with those assumptions. One of them is independence of observations. The data were collected using statistical valid methods, and there are no hidden relationship among observations. That's the first assumption. Second one, normally distributed response variable. The values of the dependent variable follow a normal distribution. We have seen how to test for normality in our last class. Homogeneity of variance. The variance within each group being compared is similar for every group. If the variances are different among the group, then Anova probably isn't the right fit for the data. A one-way Anova uses one independent variable, while a two-way Anova uses two independent variables. Okay, continue. Now, when do we use one-way Anova? We use a one-way Anova when you have collected data about one categorical independent variable and one quantitative dependent variable. The independent variable should have at least 3 levels. That is, at least 3 different groups or categories. Like you can have something like level of study can be diploma, bachelor, or master's, or bachelor, master's, or and PhD. It must be at least 3 different groups. If you only want to compare 2 groups, then use a t-test. Anova tells you if the dependent variable changes according to the level of the independent variable. For example, your independent variable is social media use, and you assign groups to low, medium, and high levels of social media use to find out if there is a difference in hours of sleep per night. Your independent variable is brand of soda. This is another example. And you collected data on Coke, Pepsi, Sprite, and Fanta to find out if there's a difference in the price per 100 milligram. Lastly, your independent variable is type of fertilizer. This is another example. And you treat crops field within mixtures of 1, 2, and 3 to find out if there's a difference in crop yield. You will see that all these independent variables are categorical variable, that is one, but of course there are 3 levels. The first one is low, medium, and high. The second one is about 4 different products. And the last one is of 3 different mixtures of fertilizers, 1, 2, and 3. Also, now, how do we now perform this test on SPSS? Let's look at this example. Following the series of complaints about poor internet connection in Malaysia, just an example, I'm not saying that, of course, some parts may be experiencing this, but this is just an illustration purpose, okay? So following the series of complaints about poor internet connection in Malaysia, a PhD scholar conducted a study to determine if certain regions of the country experience several poor connection than other regions. She randomly surveys 5 internet users from each of 4 regions and record the number of complaints she received about poor internet connection from each one. See, you are distracting me with these messages, I thought you were asking a question. I did not request for your name and your student ID. If I need it, I will ask for it in the group, okay? If you have a question, you can ask a question. That would be better. Now, is there a difference in poor internet connection between the regions? That is what the researcher is trying to investigate. That's the research question. So to do this, the first thing to do is to launch the Spss application. So when you launch your Spss application, this is what you get. Then after that, in the variable view, you create two variables as shown here. The first one is region, while the other one is complaints. Okay, so for the region part, we have 4 regions. So I've walked you through how to create this in the past. So if you are just joining us for the first time, please check our previous slide and videos in order to know how to create this kind of options. So we have these 4 options for region. Then we switch to the data view and you enter the following data into the data view. Now, after that, in order for us to conduct this one-way ANOVA, we need to go to Analyze, Compare Means, then one-way ANOVA. Now, here, sometimes you may not see the name of the variable in here. So you may actually see just the label. The label you define here. So in that case, you may want to display the name of the variable itself. So just right click, then you can see display variable name. But this is not a requirement, okay? This is just showing you that this can happen, and you can decide to, you can even sort your variables in alphabetical order, okay? This is not a requirement of the analysis we're about to do, but it's just telling you that this option is also available. So now we have these variables in here. So now the next thing we do is that you move region to factor and you move complaint to dependent variable. Now, here, unlike the previous test that we did, here we need to, last time, remember, we need to define the group. We need to define which of the group we want to do. But in this case, when we're talking about ANOVA will run whatever number of groups we have defined in this particular variable. Unlike for t-test, independent t-test will only work between 2 groups. And now that we have 4 groups, we need to specify which of the group we want to use. That is in the case of independent sample t-test. But in the case of ANOVA, we don't have to worry about that. Okay, so then you click on Post Hoc button. You select this particular option and this games whole world option. Then you click Continue. So in here, you need to click on Options again, Option button. Then here you select Descriptive, Homogeneity of Variance, Welch, and Means Plot, and the script case analysis for analysis. So you select these options. So the descriptive was selected to get the means and standard deviation of our variable. Then homogeneity of variance test for leveling test, Welch in case we find that the assumptions were violated, and means plot so that we can see a line graph of the means. So once you select this, you click OK. All these are just to check for assumption and for, of course, the test we're about to do. So once you select these options, just click Continue. Then once you click Continue, you come back to something like this. Okay, then you just click OK button. So once you click OK, you should be expecting your output window. So on your output window, the first box you'll be seeing is your descriptive statistics. These are broken down by each region. That's why you have North region, South region, East region, West region. Okay, we can see the sample size, which is 5555 for each region, and the total is 20. So that shows you that there's no missing value. We can see the name of each different integer. We can see the standard deviation as well as the standard error of the unit. We also have the confidence interval and minimum and maximum scores for each. Now, here you can see if you have gotten a value other than what you have specified in your variable, then you will know that there are some kind of error or outliers in your data set. But as it stands now, we know that this goes along with whatever we have defined in there. Now, before interpreting the Anova, we should first check the assumption of the test. And to do this, you scroll down to test of homogeneity of variances. Okay? And here, leveling test was carried out. So we are looking at complaint about poor internet connection. So based on mean, median, based on median, and whatever. So now if you look at the p-value, okay, here, you have that the value here is 0.918, which is greater than 0.05. This shows the variances are equal because the variance is not significant. The groups are not statistically significantly different. Therefore, we can conclude that group variances are homogeneous. This matches our assumption that the groups have equal or homogeneous variance because this is not significant. That means we will not need the word Anova test or games over post hoc either. But if this is less than 0.005, then we need to further check this word and games over to further do some additional to check for some other assumptions. But for now, we stop here because this clearly shows that this is not significant. Then the next box to the first one that we saw now will be Anova. Inside this Anova, we have the between groups and we have the within groups. We have the total. We have the degree of freedom and we have the mean square and value for as well as the significant value. This is the most important box that we need for this particular analysis. So to interpret and record this Anova, we will report the name of the test, which is F. I mentioned this earlier, which is F, followed by the degrees of freedom, which is 3,16. The between groups will become first, the within groups. So that's why you have 3 and 16. And of course, the F value, which is 10.45. Sorry, 49 rather. And if you are to report this, you report it like this. F bracket 3,16. We have the 3 from here, we have the 16 from here. Is equal to 10.49. You have that one here to 2 decimal places. And your p-value is less than 0.001. So you have this one here. This is the value of your p. So now you have this one here. This one is called eta squared. What is the function of this? I'm going to tell you in a short while. And how is it computed? Now, this is called effect size. Effect size. And how did they compute this effect size? The formula for computing effect size is SSB divided by open brackets SSB plus SSW. SSB is the sum of square between over sum of square between plus sum of square within. So now, if you compute this SSB, the sum of square between is what we have here, which is 37.75. And SSB again, 37.75 plus SS within, which is 19.20. So you need to sum this together. You need to divide this by the summation of these two. And that will give you your effect size, which is 0.663. Okay, so that means that 66.3, if you take percentage of this, 66.3% of the variability in complaints about poor internet connection is explained by the region which the internet users live. Recall that Anova test to see if the means you are comparing are different from one another. It doesn't indicate how different means are from one another. So the difference may be very large or it may be very small. So effect size help us estimate how large any difference we find may be. So, and that is exactly what was interpreted here. So we got this as a result of the effect size, which is eta squared with P. And how to compute this? This is a formula for computing this particular one. So anyway, this is how to report this particular equation, your Anova. So how do you now report this in APA style? Before we go there, if you scroll down, you will also encounter the Welch robot test of equality of means, or Welch Anova, which is something like this. You have this here. So if we had found Leibniz significant earlier, that is, if the value we had earlier is less than 0.005, then so in that case, we will interpret using Welch Anova, and if significant, the games over post hoc. So for now, since that is not the case, we just ignore this particular result. So one treatment is different than the other treatment, but we need the post hoc to find out which one. Now, if you look at this place, if you scroll down again, you're going to see this post hoc test. We have multiple comparison. So on the table of post hoc results, each region is compared to other three regions. You have the North region compared to South region, East region, West region. South region compared to North region, East region, West region. East region compared to North region, South region, West region, and West region compared to North region, South region, as well as East region. So the most important thing you need to look for here, of course, you see the mean difference and the standard error of the mean difference and the significant value for each comparison. Now, if a region differ by less than 0.05 in significant column here, like what you're seeing here in this second and third column or cell, those differences are statistically significant. We can see that the North region is not different than South region. North, South, you see, because the value here is greater than 0.05. Here we have a 0.94 or 0.937. Okay, so this is greater than 0.05. That's what I'm saying. North region is not different than the South region. So P is equal to 0.937. But North is different from both East and West region with probability of 0.008 and 0.001. So this shows that North is different from these two regions, but to South, it is not. Okay, so let's further discuss this. Now, the SPSS output will create subsets for groups that are the same as each other. Subsets that differ will be in different columns. Now, if you look at this place, homogeneous subsets, this is also one of the output tables you will see when you run the test. Here, you see that, you notice that the North and the South are both in the same subset. This is a subset, subset 1. This is subset 2. Okay, North and South are in the same subset because they belong to the same group. We also see that their means 1 and 1.4 are displayed. We have 1.0 and 1.4 here. The East and West regions are also in the same subset. Remember, from what we saw here, we said that, excuse me, We say north region is not different from south region because of this value, this p value. But north is different from east and west. If you look at okay, for me. So in any case, this will be grouped into two subsets. Then the east and west are also in the same subset, like what you have here. So they are the same as each other, but they are different than the first subset of the north and south region. So north and south are in the same group. We will call that low complaint because if you look at the value here kind of is less than the value you have in east and west subset. East and west are in the same group. We will call that high complaints. So the north and south group is significantly different than the east and west group. But the region within the groups are not significantly different from each other, meaning that north and south are not significantly different from each other. And east and west are not significantly different from each other. And if you look at the value between them, they're not really much. Okay? But this group and this subset is significantly different from this subset. Okay? Now, how do we report this? There was a significant difference among 4 regions on poor internet connection complaints. Then you put this equation. F, 3, 16, these are your degree of freedom. Your value for F, then of course your P less than 0.001, and of course your effect size as computed. So you change this one to 2 decimal places. Okay, and you also report as post-hoc testing reveal significant differences between pairs of regions with north, which is for mean of north is this, standard deviation is this, and south, the mean of south is this, and standard deviation is this, having fewer complaints than east, which has this, and west, which has this. These findings indicate that there are more poor internet connection complaints in the east and west region of Malaysia. That is how you conclude this. This is how you interpret this kind of result. So note that the last statement about the meaning of the finding will actually go into your discussion section of your thesis or research paper. That is, this finding indicates that there are more poor internet connection complaints in the east and west region of Malaysia. Okay, and this is how to compute and interpret what we Anova in SPSS.
Professor, what does the post-hoc testing mean?
What does what?
Post-hoc. I'm saying post-hoc.
No. I mentioned this earlier. We want to know which of these different, we are already ascertain that one treatment is different than the other treatments. Okay? And for us to know which of them are different, we need to check the post-hoc test. This post-hoc test is one of the tests that we selected. If you look at this place. Now, if you check, now, when you run this application, when you run this kind of test, it's one of the tests that will come. It's one of the outputs that will come out whenever you run an Anova test. Okay? And what do we need to do here is that we have ascertained that one treatment is different from the other treatment. That is, we have groups that are significantly different from each other, but we don't really know which of them is different. From this place now, if you look at this place, we have our within, and we have our between sum of squares. And from this place, from this effect size, we find out that 66.3% of the variability in complaints about poor internet connection is explained by the region which the internet users live. So, and we also said that Anova test to see if the means you are comparing are different from one another. It does not indicate how different means are from one another. The difference may be large, it may be small. So effect size allow us to know how large are these differences. But again, we want to further know what are the differences in this group. What are the relationship between this group? Or is it that the four regions are the same, experiencing the same internet connection difficulties, or some part are actually experiencing several one, or maybe it's not as difficult as the other region, but we don't really know which region is actually more challenged. So in order for ascertain this, in order for you to ascertain which region is actually facing more difficulties, then you need to check this particular table. And this table is the post-op test. And this is where you will know, because here, this particular table will compare each region to other regions. When it's comparing each region with other region, that's where you know which region is facing more difficulty than the other. And how can you know that? You will know that from the significant values you have here. And that is why we said, if you look at this place, if a region is differ by less than 0.05, if a region is differ by less than 0.05 in the significant column, which is here, those differences are statistically significant. Then we can see that the north region, which is here, this one, is not different than the south region. Why? Because the p-value here is 0.937, which is greater than 0.05. So that is why we conclude that this north region is not different from this. But north is different from both east and south. Why? Because the value you are seeing here, your p-value here, is less than 0.05. If this value is less than 0.05, that means this particular region is different from these regions. But still, that is still not enough. We still want to investigate more whether certain group, and this is the same way you are going to interpret all these other ones as well. So we still want to know whether we can actually separate them, or probably they can be grouped into subsets. So those that are experiencing less challenges should be grouped in one place, so in one subset, while those that are experiencing more difficult challenges should be grouped in another subset. And if you scroll down on this same output window, you are going to find another table called Homogeneous Subsets. And here, you will now see that your groups, your region, are being grouped into two subsets based on their level of severity. So now, what this means, what this is telling us is that northern region and southern region are not experiencing difficulties like east and western region. Eastern and western region. East and western region are experiencing more severe challenges than north and southern region. So it has already been classified. And this is why we mention it here that north and south are in the same group. We call that one low because of the values you have here. And of course, the east and west are in the same group. We call that one high complaint. Now, the north and south group is significantly different than east and west group. That's why they were separated. But the regions within the groups, this is a group, and this is one region. These are the regions within this group. It may not necessarily be two, okay? It may not necessarily be three, it may not necessarily be three. Okay, it may be four, it may be five, depending on the number of groups you are trying to, the number of regions you are trying to, or the number of categories of groups you have defined. Okay, this one is just 4, and based on the data set, this is what we're getting. That's why it's put them into 2. So it's not necessary that it must be 2, or it must be 1, or it must be 3. It will turn out based on what your data sets are, or what the data set is. So now, here, the regions within the groups are not significantly different from each other. What do you mean by that? Meaning that almost the same experience, almost what the people who are in East region are experiencing is what the people in West region are experiencing. So the experience in East and West are the same. It's not significantly different. The experience in North and South are also the same. But the experience in North and South is different, is significantly different from the experience in East and West. That is what this actually means. And meaning that people internet users in the East and West region faces more challenges than the internet users from the North and South region. So that is how that works. And if you want to report this in APA style, this is how you report such tests. Okay? So that is that on one-way Anova. Sometimes you may want to have 2 categorical variables. So in this case, a 2-way Anova is used to estimate how the mean of a quantitative variable changes according to the level of 2 categorical variables. So use a 2-way Anova when you want to know how 2 independent variables in combination affect a dependent variable. For example, you are researching which type of fertilizer and planting density produces the greatest crop yield in a field experiment. You assign different plots in a field to a combination of fertilizer type 1, 2, or 3. And planting density of 1 is equal to low density and 2 is equal to high density. And measure the final crop yield in bushel per acre at harvest time. You can use the 2-way Anova to find out if fertilizer type and planting density have an effect on average crop yield. So that is one. But again, when that's a scenario by which you can use a 2-way Anova. You can also use a 2-way Anova when you have collected data on a quantitative dependent variable at multiple levels of 2 categorical independent variables. A quantitative variable represents amount or count of things. Just a reminder, we have mentioned this in the past. So it can be divided to find a group mean. Bushel per acre is a quantitative variable because it represents the amount of crop produced. It can be divided to find the average bushels per acre. A categorical variable represents types or categories of things. Okay, a level is an individual category within categorical variable. Fertilizer types 1, 2, and 3 are levels within the categorical variable fertilizer type. So planting densities 1 and 2 are levels within the categorical variable planting density. So you should have enough observation in your data set to be able to find the mean of the quantitative dependent variable at each combination of levels of the independent variables. Both of your independent variables should be categorical. Okay? If one of your independent variable is categorical and one is quantitative, use an Anova instead of two-way Anova. That is analysis of covariance. Okay, so now, how does this particular two-way Anova test work? A two-way Anova with interaction test three null hypotheses at the same time. The first one is there's no difference in group means at any level of the first independent variable. Second test is there's no difference in group means at any level of the second independent variable. And the last one is the effect of one independent variable does not depend on the effect of the other independent variable. That is no interaction effect. A two-way Anova without interaction, that is an additive two-way Anova, only tests the two of these hypotheses. Okay. Now, it also comes with certain assumption, which is also goes in line with the previous one that with the one-way Anova test. Two-way Anova makes all of the normal assumption of a parametric test of difference. One is homogeneity of variance. The variation around the mean of each group being compared should be similar among all groups. If your data don't meet this assumption, you may be able to use a non-parametric alternative like Kruskal-Wallis test. Independence of observation. Your independent variable should not be dependent on one another. That is, one should not cause the other. In addition, your dependent variable should represent unique observations. That is, your observation should not be grouped within location or individuals. If your data doesn't meet this assumption, you can use a repeated measures Anova. That's the alternative test that can be done in this regard. If your observation fail this requirement or this assumption rather, the normally distributed independent variable, the values of the dependent variable should follow a bell curve. If your data doesn't meet this assumption, you can try data transformation. That is, you can transform your data in order to get a normally distributed dependent variable. So these are some of the assumptions that come with two-way Anova. So how do we now perform this test on SPSS? So let's imagine for some reason, in this example, we are interested in the eating habit of monkeys. So we look at, do male monkeys eat more than female monkeys do? Do they prefer red fruit over yellow fruits? These are the two questions. One, do male monkeys eat more than female monkeys? Two, do they prefer red fruit over yellow fruits? So in this case, our between, so in this case, our between participants variables is going to be sex, which is male or female. But we are going to give both groups two types of fruit, which are red and yellow, because they are within participant variables. So to do this, you need to launch your SPSS application and create the following variables. We have sex, red, and yellow. Okay, of course, the sex will be a nominal variable because you're going to be a categorical variable, and you're going to add certain value, which is male and female, to this particular variable. So once you are done with this, this is what I was saying. So for this sex, you need to add these values for this particular for your first variable. So then once you are done with that, you switch to your this now. Once you are done, you switch to your data view window. Then you enter the following data for this. All these data are just sample data, okay? So you can use any form of data sets just to set. You can download it. There are a lot of sample data you can use to, but this is just for illustration purpose. Okay, so we enter this. So wherever you see 0, it's represented in male monkeys, and wherever you have 1, it's representing the female monkeys. So, and of course, you have the number for red, number for yellow, and the likes. So we now have our data set up. So the next thing is to run the analysis. So to run this analysis, what we need to do is to go to Analyze, click on General Linear Model. Then you click on Repeated Measure. So once you click on Repeated Measure, this will open for you. This page will open. So here we need to give a name to our foot variable. Okay, so which is our within subject factor. So here we just give foot color. You can give any name of your choice. Okay, so number of level should be 2 because we have 2 variables in there. So number of levels should be 2. I mean, yeah, 2. Those are the colors of the foot, which are red and yellow. So once you enter this, you just need to click on this button called Add. So once you click on this Add, this is what you'll be seeing. Okay, so once you see this, the next thing you do is to click on Define. Okay, so once you click on Define, that will bring you here. So you enter your variable as shown here. So once you enter your variable, you put this one in this place. The next thing you do is to click on Options. So when you click on Options, this is what you will be getting. So all you need to do is select Descriptive Statistics as well as Homogeneity Test. And of course, significant level will remain at 0.05. Then you click Continue. So once you click Continue, that will take you back to this page. So all you need to do is to click on Email Means. So that is estimated marginal means. So in here, you take this sex and foot color variable, you put them in here. Okay, so then once you're done, you click on Continue. Then you should have something like this back. So the next thing you do, you just click OK. So once you click OK, remember this 1 and 2 are just a category variable because you have already choose 2, right? When we enter 2. So that's why this one will come automatically. You don't have to worry about this. It's just an order. So now, before you interpret your result, we need to first check the assumption to be sure that we have not violated any. So to do this, scroll down to box text of equality of variance matrix, which you have something like you have your M value, you have a box M value, you have your DF1, DF2, they have a sig value. So here, the P value here is what we are actually concerned about. So the P value here is not significant because it's 0.111, which is greater than 0.05. So therefore, it is not statistically significant. Then if you go to level test of equality variance, you will see that the value here, the P value for both variables are also greater than 0.05. This one is all the value you have in here are greater than 0.05. So the same, these two tests are telling us the same thing. Okay. So once all the assumptions have been made, next is to check for the test of within subject effect. So if we look at foot section, foot color created section under test of within subject effect, and we look at the significant value here, which is 0.341. This value is greater than 0.05. So there wasn't a main effect of foot color. So overall, red foot wasn't more popular than yellow foot, and yellow foot wasn't more popular than red foot. That's what is actually indicated. So if we look at the test of between, scroll down a bit, you are going to see this test of between. So if you look at this test of between effect, you can see that there was a significant main effect of sex because P is less than 0.05. Okay. So now, how do we report this? Then after gathering all the overview of our output, the next is to report. To do this, you can simply write this as follows. You can say a two-way mix Anova was conducted to investigate the impact of sex and fruit color on food consumption. Then there was not a significant main effect of food color. And you report your F 1,18. These are your degrees of freedom. And the value of your F, which is 0.96, and the value of your P. However, there was a significant main effect of sex. Then you say F, then your degree of freedom, then your P, which is less than 0.001, with male, which is the mean of male, 17.1, consuming more fruit consuming more fruit overall than female, which is of mean of this particular size. Additionally, there was a significant interaction between sex and food color. Then you report this as well. So all these figures, you find them from the table we have mentioned here. Okay. So this is how to report a two-way Anova test on in APA format. Now, another thing that is also very important and quite essential is chi-square test. Chi-square test, I remember I showed you this on how to compute this in Excel. But in most cases, you always want to prepare this on SPSS, especially if you are using SPSS for your analysis. So it will be a good idea to know how to perform this test on SPSS. There are two types of chi-square tests. Both use the chi-square statistic and distribution for different purposes. So we have a chi-square goodness or fit test that determines if sample data matches a population. We also have a chi-square test for independence, which compares two variables just able to see if they are related. So, as you put your related report, okay, so in a more general sense, it tests to see whether distribution of categorical variables differ from one another. So a chi-square statistics is a test that measures how expectations compare to actual observed data or model results. So now, how do we now compute this in SPSS? It's also very simple. Excuse me. I'm trying to allow her again. Probably she will mute herself now. So, chi-square test of independence of SPSS. So in this example, we look at the different types of clothing that people wear in different countries. So we have a relatively cold country like Scotland and a relatively warm country like Spain. So we can ask whether the frequency with which people wear t-shirts versus jackets in those two different countries varies. That's what we want to investigate. So to do this, we can straight away create these two variables on our SPSS. So we have country as well as clothes. These are categorical variables. And of course, we have values for each of them. For country, we have Spain and Scotland. And for clothes, we have t-shirts and jackets. So here, this is how these particular values are defined. For Scotland, it's represented by 0. while for Spain is represented by 1. This percentage, this decimal point are coming because of this 2. So after this, of course, I change it to 0. So then for clothes, we enter 0 for t-shirt and 1 for jackets. That is for clothes. So once you're done, then you enter this value for these variables. So once you're done, in order for us to perform this test, then you go to analyze. I hope she's here. Yes, you will join it. Okay. So you go to analyze, then click on descriptive statistics, then select cross tabs. So once you select cross tabs, then that will bring you here. So move your independent variable into the row box, which is here, and move the clothes into the column box. So once you're done with this, you need to click on statistics button. Once you click on the statistics button, this is what you'll be seeing. What test do you want to perform? Just the chi-square test. Okay, just the chi-square test. So once you check this, just click on continue. So once you click on continue, this will bring you back to this place. Okay. Then here, the next thing is to click on cell. You're going to see cell. So click on cells and this will come up for you. So for count, you click observed, and for percentage, you select row. For this one will be chosen by default for you, so nothing to worry about. So you click continue. So once you click continue, this will bring you back to this. So you just click OK. So once you click OK, you have certain outputs like this. Okay. From the output window, we can see that in Scotland, when you see country by clothes cross tabulation, you will see that in Scotland, 20% of people wore t-shirts and 80% wore jackets. In Spain, 65% of people wore t-shirts, while 35% of people wore jackets. Okay, now, if you scroll down to the chi-square test table, okay, when we look at the number in the chi-square table, which is here, so you see that the significant value in the chi-square row is 0.004, which is less than 0.05. So because of this, we can therefore say that there was a significant effect of country on the frequency with which people wore different types of clothes. So how do we interpret this? So we can simply say that jackets were worn by a higher percentage of people in Scotland. That's what you see here, which is 80%, compared to people in Spain, which is 35%. They cannot say that a chi-square test of independence revealed that jackets were worn significantly more often in Scotland than in Spain. They can have this symbol, which is chi-square symbol, open bracket 1. 1 is your degree of freedom, which you have here. And n is 40. That's where you have number of valid cases. And your chi-square value is 8.29, which you have here. Here you have 8.286. So, if you run this to 2 decimal places, you have 8.29. And of course, your p-value is 0.004. So this is how to report a chi-square test and how to compute a chi-square test on SPSS. Okay, so that is that on that. Now, last part, which is on questionnaire. This particular aspect is quite important, and that's why I've decided to add this part. In any case, some of us will be collecting using questionnaire as your data collection tool. After you have collected your questionnaire, how do you convert that data into variables on SPSS. Now, sometimes your questionnaire, depending on how you want to do, you may create based on your research, and you may actually adapt from a particular theory or framework, depending on the nature of your research. So, in any case, you must know how to interpret or how to transform that questionnaire into variables, and that variables, how to key them into your SPSS in order for you to be able to enter the correct data for them and in order for you to run your analysis. So in this section, we'll take a look at how to enter questionnaire or survey data into SPSS. It is important to make sure that you know how to do this when you are working with SPSS, in particular when you are entering data from a survey. So to do this, we have created a sample questionnaire, which I will be showing you in a short while. Similar, we created a code sheet from the questionnaire. This will guide us to create our variables on SPSS. In this, in that questionnaire, we have 5 questions from what is called satisfaction with life scale. This is a popular scale. This is a theory that a lot of people, a lot of researchers use to do certain investigation. And this particular scale, it has a predefined questions, and it has level from 1 to 7, which range from strongly disagree, disagree, slightly disagree, neither agree nor disagree, slightly agree, agree, and strongly disagree. And these are the questions that comes with this particular scale. The first one is, in most way, my life is close to my ideal. The condition of my life are excellent. I am satisfied with my life. So far, I've gotten the other things I want in life. If I could live my life over, I will change almost nothing. So these are the predefined questions that come with these theories. So this is one of the beauties of adapting theories or tools that has been established. If you're adapting tools or theory that has been established, it will make your work faster because you don't have to prove anything again, because it has already been proven that it's workable. And the questions you need to ask are actually there. So what you need to do, probably you may need to combine two, depending on the nature of your research. So maybe you are combining 2 or you are combining 3 or to do certain investigation. So what I'm trying to say is that you don't have too much to prove that this tool is actually measuring what you're trying to measure. So, but in any case, anyhow you have your questionnaire, just make sure you do it properly. So this is an example of a simple questionnaire that we have designed. So here we have question 1, 2, 3, 4, 5, 6, 7, 8. Now the first 3 are like, you have what is your gender, we have male or female, what's your ethnicity, we have a list of certain ethnics. Then we now have an option here called others, please state. Then we have another one here, what is your age? Then they enter the years and years. Then the next stage is that below are 5 statements that you may agree, or disagree with, using the 1 to 7 scale below. Sorry, it's not 5. 1 to 7 scale below, where 1 is equal to strongly disagree, 2 disgrace, that may disagree, 3 slightly disagree, 4 neither agree nor disagree, 5 slightly agree, 6 agree, and 7 strongly agree. Answer each of the following, that is, circle the appropriate value as they apply to you. What is the first question? In most ways, my life is close to my ideal, which is the same question that was shown in the theory in the previous slide. So your your respondent is expected to circle only one option in these 4 options. So after you have collected your data in this case, how do you now prepare? How do you do a data entry on your SPSS using this kind of questionnaire? The first thing you need to do is to create a code sheet. And what do you do in code sheet? You identify your variables. From your variables, you know which one will be categorical variables and which one will not. So here for this code sheet, we have for the first question, what is your gender? So the variable here will be gender. And it's going to have these values, male and female. So 1 will represent male, 2 will represent female. What is your ethnicity? Ethnicity here will be your variable. And the values you'll be having under this ethnicity will be Nigerian for 1, Malaysian for 2, Chinese for 3, Indian for 4, Sinhalese we have 5. And you now have another option here, say others. So that will be 6. But it's a way by which you will enter this in SPSS. I'm going to show you in just one. Then you have another question here, which is what is your age? So age here is also a variable. So you identify this as a variable. Then these other ones, you can see that these are questions that were adapted from a particular theory. So with that, you can straight away just code them as SWLS1, first question, SWLS2, SWLS3, SWLS4, SWLS5. Okay, SWLS stands for satisfaction with life skill. Okay, that's what we have here. And these are the questions that we ask that come with this particular scale. So in any case, you first need to identify your variables in order for you to know how you are going to do the data entry. So after you have identified the variable, you have defined your code sheet. So then based on that code sheet is what you're going to use. You're going to follow that code sheet in order for you to create that variable in your SPSS interface. So to do this, you go to your SPSS. So of course you create gender. So when you create gender, you enter values, 1 for male, 2 for female, based on what you have defined here. 1 for male, 2 for female. Then you have ethnicity. Okay, now to enter value for ethnicity, you have this. It is 1, 2, 3, 4, 5, 6. Okay, now we now have another option here, which is others, please state. Others, please state. So meaning that the option here is not here. So your user will need to type in their answer into this place, or write in their answer into this place. So in that case, whenever we have a box or an entry that people can type something, that one needs its own variable. So in that case, you need to create another variable called order underscore ethnicity. So we know that it goes in line with ethnicity. So in that case, then you change the data type instead of using numeric. Remember that other ones were represented with digits, with figures, 1, 2, 3, 4, 5. So even though this one was also represented with figure, but again, when your user want to enter their values, they will not enter number, they will enter the name of their ethnics. Okay, the ethnic they belong. They are going to enter the name of the ethnic they belong. So that is not a digit, that is a string. So that's a text rather. So now for you to change that type to a text, you need to click on this type, and here you're going to see string. String is a data type that allows you to enter a text. Okay, so you click on string. Then if you think that the value they may enter may be really very long, that will be more than 30 characters, you can increase this. If you think that it will not be more than 30 characters, then you can leave it as 30 by default. Okay, so then you click OK. So once you are done with that, then for age, you can create another variable for age as well. Just it is straightforward something. Then for SWL, you can create SWL has, we have 5 questions there. You can create a variables like this. So once you are done with this, of course, you need to enter a value for this SWL as well. So since all of them have the same number of values, it's even more it's more easier. So you only create this for one. So once you're done with this, then you right click on that one, then you select copy. So once you select copy, then you select these three or this remaining four. Once you select this remaining four, you right click on them and click paste. Once you click paste, the same thing that was created, the same values that were created for this SW health one will be pasted in these other four variables. So we pasted for these other four variables. So that is what makes this even interesting, because it makes your work faster. Okay, so this is how you can create a variable from your, this is how you can do data entry from your questionnaire. So after you have done with this, okay, so the next thing is you switch to your data view. So when you switch to your data view window, this is what you will be seeing. Okay, you have your all the variables you have created. So for example, we had a male who is a Chinese, and to make it easier, he answered 6 on each of the SWLS questions. So our data will look like 1, which is male, ethnicity is a Chinese, other will not there won't be anything there because I already chose the ethnicity. Then you put the age, then you enter 6666666 for all this. Okay, then we have another variable, which is, we have another respondent, the second case, which is 2, that will be a female, then who is from this should be from Nigeria, then the age is 21, yes, it choose 4. Then the third case is 2, which is also a female, ethnicity, I think from Malaysia, then the age 23, and the values have also entered. And the last one is a male, and his own ethnicity is other, because this ethnicity is not part of what was listed. Then because it's other, he or she need to enter his ethnicity here. So that's why it said Latvian Finn. So because from Finland. So he put this, then the age is 32, and he chose the following values for his inputs. So this is how you key in your data from questionnaire. So after you are done with this, then you can straight away do your analysis. Okay, it is as simple as that. So if you have any question, please let me know. So anyway, before we go, lastly, if we have hard copies of these surveys and we have administered them to people by hand, often we will want to keep track of each individual survey with a number. That is, you may want to add IDs on each of the surveys. So you can put something like 001, 002, 003, and so forth, especially when your survey is quite large. Okay, so in that case, you may want to keep a track. You may want to keep track of that on your SPSS data view as well. So how do you do that? You go to your data view window, then you right click on the first variable, which is gender. Then you click insert variable. So once you click on insert variable, that will insert a variable of this kind for you, which has missing values. So in order for you to change the name of this variable to a suitable name, all you need to do is to switch to variable view window. So once you come to this variable view window, then you can straight away click on that new variable that was added and rename it to whatever you want. Okay, so once you rename it, you can change this one. Of course, you need to change this to integer. Okay, to numeric rather. So you change it to numeric and a few other things that needed to be done. Then once you're done, switch back to your data view window. Then you can enter those IDs as shown here. Okay, so once you do this and you have all your data, then the next thing is for you to do your analysis. So that is how to do survey entry on SPSS. Okay, so on that note, we have come to the end of this section, but there's something I quickly want to show you before we go. I will I'll send the attendance sheet so you can click on it and fill it up. One of you contacted me during the week. So I was not able to prepare much on sensitivity and specificity. So you can check on these. And I've also added a short video that you can actually watch in order for you to know what's and how to go about this particular area. It's very simple. It's not a difficult one, but I need time to do. But with this, I believe you should be able to do. Then also, you also request for how to write a research hypothesis. It's also very simple. Just check this list, check these links, as well as this YouTube video will also help you on how to create a formidable research hypothesis. And also research objective as well. Check this link. All this will help you a lot on how to repeat all these areas. So once you're done with that, you'll be able to get your work done. So on this note, we have come to the end of today's session. So if you have any question, please let me know.
Thank you, sir.
Thank you. So, sorry.
Thank you. Thank you, sir.
I'm going to upload the notes and as well as the link in the group later. So please go there and check. So I wish you all the best in your research journey. And if you face any issue related to what we have discussed so far, you can always reach out. And if I did not reply immediately, please be patient. I will surely reply you. Okay. So I wish you all the best and enjoy the rest of your day. Bye.
Sir, one more thing. Please give the email address for getting the supervisor.
Yeah, please send me a message. Okay, send me a message on WhatsApp.
I'll do. Okay, sure. I'll do.
All right. Thank you.
Thank you, Professor.
Bye.
Thank you, Professor.
It's our last